Hey, it is me, Onomi, and this is an internal trading video at Onomi Games, where we'll learn to project textures onto a model in Blender, and then save that as images that you can easily edit in your image editing software. So this is a model that I made. It's vaguely based on this reference, and it's really supposed to be one of these game models, which does not have a lot of detail on the actual model, but you're supposed to add the detail using textures. So the most common ones would be the color texture and the normal map texture. And you can get a lot of detail by just using those two. And then you can add metallic textures or specular textures, ambient occlusion. It can go very deep. But the foundation you need for all of those is one single base color texture that you can draw all of that on top of. And that's what we're going to learn to do today. So the goal is to turn this completely gray, colorless car into a colorful car without actually drawing on top of it or anything like that. That's also an option, but today we'll be using something called projection. So whatever reference you might have used to build this car, like you might have a front, back, left, right, all of these things, we'll just project these onto the car from different directions and then bake that into a texture. So the first thing we're going to do is go to the UV editing panel, and from here we can open to load our different reference textures. And we have 6 directions here. We have top, bottom, left, right, front, and back. So we can simply load it like this, and it will be listed over here. Be sure to name them, like I'll rename all of them to 00 car and the direction, so they stay on top nicely without being mixed into all of these other textures. So let's look at the left one. And changing the view here, you can kind of imagine how this texture was used to model this car. But now what we're going to do is project this onto this in directly this direction. So we should go to the X direction orthographic view like this. And then we can simply go to UV, project from view. And from here you can see it's not exactly aligned. So you should use the transform tool to scale it and make it fit better. But you can see it's not fitting that well still. Like the wheel cavities are not aligned, even though the rest of it is aligned. This is usually a sign. This is usually a sign of, like, this exact reference was not used to build this vehicle. It was probably like a little bit different maybe, but close enough that we can still texture it. And the way we can do that is by simply selecting the vertices and moving it around so everything fits nicely. Now it does not have to be exact, and also you don't have to worry too much because you can always come back and fix this later. The one advice I'll give you here is to make sure that our UV projection is within the image of the car. Like, let's make sure no vertices are like outside in the white area in the background. Otherwise we'll have white outlines, which is not nice. So if it is within the image and vaguely lined up, then it's okay. Okay, so now we have this ready. We can, in the inspector, go to the data panel, and we have UV maps. The one we just made right now, like this, it's the default one. It's just called UV map. However, we can rename it. Okay, I'm going to rename it to 00 car left UV, so it matches our image, 00 car left, but of course it is the UV. Now we need to do the same thing for all of the other ones as well. Okay. I will make one more. And I will name this 00 car UV. It's not attached to any direction because this is the one we will use in the end when we bake and export the texture. Okay, so now that we have all the UVs, we need to set them up. So this is the left one. Let's click on right. You can see over here that it's selected. And now we can flip it around. We can select the correct image. We can select every vertex. We can select every vertex by pressing A. And now we can project from view. And now we can go here again. Use the transform tool. Now you can see when we click car left UV, it shows the left one. And I can select the correct image to make it match. And when we click on car right UV, it is selected over here and it shows the right one. Okay, so this is how we can continue. Let's do the top one now. So in this case, I'm going to match the windscreen. Okay, that is good enough. Now we can move on to the bottom. And let's do the front and the back. Okay, so there is one problem we need to address here. The front view of the car, the image, it's not exactly front view. It is a little bit from higher up. So we can see some roof. We can see that the rear wheels are a little bit higher up than the front wheels. So this is not an exact front view, but that does not really matter. Because what we can do is kind of try to match the view like this. I moved the camera a little bit far away because from up close, you can't really see the rear wheels. So the FOV is not matching. But if I zoom out, the FOV is more similar to what is here. And it looks smaller, but that does not really matter. Once you project from view, you can make it bigger. That is good enough. And finally, we need to do the car back. Okay, that is good enough. Do remember that you can always adjust these later. It does not have to be now. Okay. Let's review what we have done here. If I click on left, and then I select the left image, you can see that this projected UV correctly maps to the car's left. If I select right, select the correct image, the car's UV is properly mapped to the right, and so on. For things like front and back, which was not completely aligned to the axis, we simply projected from slightly off axis. So it worked out anyway. So this is a powerful technique. You can use it to map not just the reference you use to build the model, but other references as well. Even if the car looks different to your model, you can still UV map it and fit everything inside the image so that it'll still look good in the end. Okay, now let's move on to shading. Okay. And now it is time for shading. Our goal is to project the images on the car from various directions so that the whole car looks properly textured. And the way we're going to do that is by adding a material. So let's add a new material. I'm going to name it something descriptive. And you can see in our shader graph, we can see principled BSDF. And if I increase the metallic, the shininess of the car goes up. Let's start with only one direction, the right direction. So the first thing we need to add is an image texture. We can select the car right and assign color to the base color. Okay, you can see that the image actually is on the car now, but it's very strange. There's lots of stretching over here. It's actually backwards. And from this direction over here, it looks kind of okay. But that's because our default UV is on the left direction. Okay, so let's fix this. Instead of using the default UV, we need to use the right side UV. So you can go to Add Input and click on UV Map. And over here, we can select Right. Now you can see from the right side, it actually looks okay. But from the top and bottom, it looks very stretched. This does not look right at all. Now, even though it looks okay from the right, and from the left you can actually read the Wacom, so maybe we swapped out right and left? Okay, it does not matter. We're just going to pretend this is the correct, like this mirrored text is the correct text. Okay, so from the right side it looks okay. But we only want this image to show up in the right side. And the way we can do this is by comparing the normals of the polygons to the direction we want. So the right direction is the positive x direction. And we can check whichever polygons have a positive x direction normal or something close to it. We can use more of this texture. And if it does not have, like if it is facing the wrong way or a perpendicular direction, then we can keep it black. And the advantage of keeping it black is that we can simply add a different projection to it and everything should look fine. Okay, so let's do that. Right now, this color is our output, but we need to ensure that this output is multiplied by a number that correctly compares the direction of the normal of the polygon to a direction of the UV map. So the first thing we should do is define the actual direction of the UV map. We can do that by adding a combine XYZ node. And what this does is it takes in X, Y, and Z values and outputs a vector. Now our right side is in the positive X direction. So I'm going to set X as 1. Next thing I need is the normal of the surface that is under consideration here. And we can get that from the geometry node. So in input, we can set a geometry, and we have normal right here. Now we need to dot product the normal with this vector. A vector math node, and select dot product. Let's set one of them to normal, and the other one to our combine XYZ. Now this is our dot product. Finally, we can add another vector math node. By the way, make sure this is vector math and not normal math. Make sure this says vector and make sure this says vector in the output over here. We can set it to multiply, and we can multiply the color with the dot product. And we can pass this to base color instead. Now let's look at the car. You can see the polygons that are facing right, they're getting the correct colors. And the polygons in the opposite direction or the up direction or any other direction, it all looks black. So this is the correct way to projection map on just one direction. You can see a little bit over here as well, and that's because these polygons also face a little bit towards the right, but it's a small thing, and if it needs to be adjusted, we can remove it from the UV map from here, but most likely it will be fine. We won't even notice things like this at the end. So now we have correctly mapped the right direction to the car, and the texture appears correctly. Next thing we need to do is to do this 6 times for all of the directions, and then add them all together. Now, you might realize that is a lot of work, like doing all this 6 times, but you don't have to. What you can do is group the nodes. So let's take all the nodes and make a group. As you can see, all our things are packaged nicely into a single node, and you can imagine that we just need to make 6 copies of this, and then add all of their outputs together, and then send that to the base color. And that should be done. However, I'm going to do something a little bit clever here. What I'm going to do is make this node group be able to cumulatively add things. So instead of using extra addition nodes, we can simply chain all 6 of our views, the projection nodes, and then the result will simply be the sum of all of them. Okay, so in the group, you can see we have 2 things, the group input and the group output. Okay, so in the input, we should take the previous image in the chain and then add it and send it as the output. Okay, I've added a thing, like an input thing here called cumulative input, like this. I'm going to set it to color, and this is our input. Now for our output, I'm going to add 2 of them. This one is just for testing. So if we directly hook up pure output, it will only show this projection of this direction. And this is correct. It should simply take our multiplied thing. However, the cumulative output will simply be the sum of the output and the previous cumulative input. First of all, don't forget to make these image types. Don't forget to make these color types. And now we simply need a vector sum. Okay, our module is ready. It takes a cumulative input, so the previous image, and then it adds this projection to it, and then its cumulative output comes out. Okay, so I'm going to exit like this. You can see it's a little bit more complicated. It has many sockets now. It has the pure output, cumulative output, and the cumulative input. It also has a name. I'm going to name it 00 car projection right. And I'm going to give it a shield so it's protected. So it's and I gave it a shield, the fake user, so it's protected even when it's not used. So if you accidentally break this, it won't be deleted. Okay. Now here I duplicated it. And you can see if I change this to left, both of these change. And that's because when you duplicate it, it's not a copy. It's the same instance. This one references this, and this references this. So whatever we change inside this will change here as well, which is not very useful. It is useful if you have a very big graph and you want the same inputs to appear in multiple places without having really long connections everywhere. But of course, in our case, we want these two to be completely separate. So I can just click on that number over there, And if I click on it, it becomes a copy. I can give it a fake user as well. I can name it left. When we open it, you can see that it has the exact same things as the right side projection. So we can slowly just change everything to the left side. The UV map should be left. The combine XYZ should be in the negative X direction. The car right should be car left. And that should be enough. There is one thing I would like to add. Okay, there is one thing that I might have overlooked, and that is a clamping. The dot product will release both positive and negative values. And when we multiply color with positive values, it's fine. It just makes it brighter or dimmer. But when we multiply it with negative values, it might cause problems while adding things. Visually, the color might just look black, but it might be a negative color, or it might be fine. The thing is, we just don't want to deal with ambiguity like this. So let's clamp our dot product result between 0 and 1. So this is exactly what we want, clamping from 0 to 1. Now let's exit our group. And we will have to do the same thing here, because we copied it before we did the modification, so now we have to do it twice. Okay. You can see the left side still is not here. You can see the left side still is not here. And that's because we're still using the pure output from the right projection in our base color. Instead, we should send this output to the cumulative input of projection left and attach its cumulative output to the principled BSDF. And now you can see our car has the correct projection from the light. And now you can see the car has the correct projection from the right and from the left. I know this text is backwards, but that is how it was in the reference, so this is how it's supposed to be. You can see it's the same in both sides. So it's not like the right projection is passing all the way through and visible on the left. The correct orientation of the text is visible on both sides. Okay. Okay, now you get the idea. Let's do the same thing for the top and bottom as well. As a reminder, this is what we need to do, and this is what we need to do. We duplicate it. We copy it by clicking on the number. We rename it. We go inside. The direction of top is the positive Z. So we set that in our combine XYZ. We select the correct UV map. We select the correct texture. And that's it. Now in our main graph again, we send the cumulative output to the cumulative input and send the cumulative output here to the base color. Now you can see our car looks even better. We have the top texture. But the front still looks stretched and strange. And the rear could do with some more detail as well. And of course the bottom does not have anything. So we can add all three of these. So let's add all three of these. We duplicate, recopy, we rename, we go into the node group. And here there is a little bit of a problem. And that is that our front direction is not exactly the front direction. It's a little bit, it's a little bit higher up. However, it actually should not matter too much because this combine XYZ is simply to make the texture lighter or darker based on the direction. And if it is close enough to the front direction, then it should be fine. Okay, that's good. Now the front of the car should be visible as well. You can see it's okay. There's some texture doubling here. That's because our maps were not perfectly aligned. And also in our reference themselves, and also in our reference images, all the directions don't really match. Also in our reference images, the directions don't exactly match. Like the car image actually looks different because all of this was generated by AI. So yeah, we're going to get some image doubling like this. But there are ways to fix this later, either while creating the actual textures or... Okay, now we're up the front. It is a little bit dim, so maybe it would do good to make the direction a little bit higher. And the way to do that would simply be to use a mix of the positive y direction and the positive z direction. So if we set it like this, then maybe it should have gotten a little bit brighter, but not really. One thing to note when you're doing this, like directions that are not aligned with the axes, you need to make sure the magnitude of this vector is 1, because then the dot product will always be 1, and no information will be lost while clamping. Alternatively, you can use a normalized node. Like this. And this means no matter what values you put here, the output will always be 1 in magnitude. Let's do the same with the rear of the car. Okay, so that is the back. We can select those like this. That will be the negative y direction. However, it's still from slightly above, so the z will be positive. You can see at the back of the car is textured as well now. Finally, we have the bottom of the car left. Okay, so after projection mapping from all 6 directions, you can see our car is fully textured. You can see that the left and the right have different direction of the text. You can see there's no stretching. However, you can see some problems as well. Like, this does not really match where the windscreen is. This does not really match where the windscreen is. There's a little bit of double textures. Maybe there's a tiny bit of stretching. There's many instances of things fading into each other. And you might be okay with some of these and not really okay with others. But the thing is, in the end, this is not a final step. You'll have to do more work after this. This is just to get you to a point where you can map your reference images onto your actual model. And this itself becomes a reference for texturing later. This is an alternative to straight up drawing on top of the texture using texture paint and then using that as a reference. It might work better for references which are consistent so that there's no doubling. It might work worse for textures where the top view and the side view and others don't really match. It might work okay for textures where there's a lot of fine detail. So when things are fading into each other like this, it looks okay. But if there's clean lines like this, it looks kind of off when it's fading into each other. So yeah, lots of pros and cons. But personally, this is a really good first step to later go to Photoshop and adjust these textures so it works out. However, we're not done. We actually still have to bake all this. Before we do any baking, if we go here to the UV editing panel, you can see that our car is textured when you click on this viewport shading thing. And also, you can still edit all of these UVs. So for example, you can see there's a little bit of double texturing here. So maybe I can select these 3 and move it so that they match with each other better. Like I said, you can edit these UVs even after doing all this in order to minimize the artifacts a little bit. So once you're done adjusting all this so it looks okay, or you're okay with it for now and you can think about editing it later in Photoshop, we can begin with our final UVs. So this one. For that one, we need to create a brand new texture. So let's create a new image and I will set it to be large, 2048 by 2048. I'll call it unwrapped, and you'll see why just in a minute. And you can see the image is completely black. Now, we're going to bake our texture on top of this image. But first of all, we need to properly unwrap our model. So I can select all faces, like this. If I go to UV, into unwrap. And it's all squished onto the side like this, and that's still the left view. So instead, let's do the Smart UV project. And you can see now our car has been split into many different parts. You can see that this is kind of the top part, and these might be sections of the side part and everything. However, this is not ideal. However, this is not ideal for our purposes. If there's lots of different separated sections like this, then it becomes more difficult to texture it. So if you go to Photoshop, for example, and this part of the car and this part of the car right next to it are in different parts of the texture, then it becomes a lot more complicated to draw it in Photoshop. And especially make it seamless, like make it so that there's no disconnect between the two different parts. So we need to minimize that as much as possible. And you can maybe try in Smart UV Project, increasing the angle limit, for example. That makes it so that there's less pieces. So in this case, you can see that this is probably the bottom of the car, and this is the top of the car. One of the wheel cavities, it's outside. And there's lots of little sections here, which are probably like these indented sections or these bumper sections. It's better, but it's still not ideal. So, how would you professionally do this? And the answer is by marking seams. So if you can kind of picture which parts of the car you want to be different sections, you can easily go to the edge view, and then you can select which parts you would prefer to be seams. And by seams, I mean like where it's okay to make a... So we can just go to edit mode and select whichever edges we want to be seams, and then set them as such. Okay, I've gone to the modifiers and disabled the visibility of the subdivision surface, and this way I can see much more easily. So I've selected the front section here, this much. Now that I think about it, I don't think we should have a seam here. Instead, it should go down like this. Okay, I'm happy to make this a separate section. So I can simply mark it as seam. And seams are marked in red. So this is the front part of the car. Now let's make the hood. Okay, I'm done marking the seams now. And let me show you the main sections that I've separated. First, this is the hood of the car. Second, the front of the car like this. Then the sides of the car, which includes all of this, all the way to the back here. It does not include the window, and the windows themselves are their own sections, including the windshield. There's the top section, which contains the roof all the way again to the back, and also the two window separators. And then there's this rear area, the rear bumper, and of course the bottom. And the inside of the wheels become their own sections. So this is one way to mark the seams in, well, something that looks like a car. And now if we select all of our faces and go to UV unwrap, you can see that all our sections are separated properly. And now you can even recognize them. Like these are the side parts of the car, obviously. This is the bottom. This is the roof and the rear. These semicircular things are the insides of the wheels. This is the hood. This is the front. This is the back bumper. This is underneath this one. Like, this is the back light section. This is the bumper. This is one of the windows. This is the other window. And this one is the windshield. Now you could be happy with this, or maybe you're not very happy with this, because we don't want this much of the texture to be dedicated to like the bottom of the car. The tire sections could be smaller as well. The hood, it'll probably help if the hood is nicely sized and shaped. Like if it is shaped with a better aspect ratio like this. It won't look stretched when we bake it. So you can use your judgment and move all of these around. So let's do that. So first thing I'm going to do is move these separate from each other so that I can edit it more easily. First, everything looks squished in the X direction. So I'm going to select everything. And stretch it like this until everything looks okay. Next, I'm going to go to this viewport and press A so everything is selected. And then in the UV map, I'm going to click on UV sync selection. So what this does is that it puts all of the selected faces here, but they won't also be selected. And what this allows us to do is, say, click on this vertex and go Control plus repeatedly until we have selected this whole thing. And if you keep going Control plus, it's not going to bleed over into the other parts. Okay, so now they look a little bit better sized. We can think about which ones can be smaller, which ones can be bigger. Like first of all, bottom of the car. That can be smaller. I'm happy with that. This is the top of the car. I think that's a good size. This is the hood. I think that's a good size too. Okay, I think I'm happy with this. The bottom of the car is small, the wheel cavities are small, and the important parts of the car are bigger. This one might be a little too big, but it's okay. Okay, so now that... Whew, I'm a little bit tired, I'm sorry. So, once you're happy with your UV mapping, we can go ahead and bake our projections onto this texture. So you just have one single texture to work with. Edit in Photoshop, whatever you want. First thing we need to do is to go back to shading. And we need to make sure the texture is being baked on the correct image. Now, what it does is it just takes the node you have selected, and if it has an image in it, that's what it bakes like the whole thing on. So we should add a new image texture, like a new node like this. We don't need to connect it to anything right now. We don't need to connect it to anything right now. But we can set the image to the new one we created, 00 car unwrapped, and make sure this is selected. Next, let's go to UV editing. Let's exit out of edit mode. And with the object selected, let's go to the render tab. We need to change the render engine to cycles. And that will make this new panel show up, the big panel. We can set the big tab to diffuse because we're only baking the color. We can remove the lighting and make sure the target is image textures, so it's the one selected in the shading tab. Then return to tick. And once the baking is done, you can see our texture right here. The entire car has been unwrapped, and the whole texture is now in a single texture, which we can use. It will be saved as 00 car unwrapped. And if we go to shading, we can move this up here. We can use our 00 car UV map. Set that to vector. And set the color like this. Now you can see the car looks basically the same as before, but instead of doing all of this projection, it's simply using one texture and one UV map. And this is how it will be in the game engine. So let's look at our baked texture again. You can see that it actually contains some of the artifacts that I mentioned before, like doubled textures, things fading into where it should not be. And well, now it is the task of the artist to take this to any image editing software like Photoshop maybe, and then clean all of this up. Maybe overlay like the actual reference images on this. It's just much easier to start with this than start with nothing. So that's why we do all of this projection. One more thing, if you want to know how to save this image, you can click on Image, then Save As. One thing you can do that's very helpful is actually save this, like the layout, with all of the polygons and vertices, as an image itself. This will also help determine exactly where the boundaries are, and maybe give you a hint of what parts of the car is where when you're editing it in your image editing software. So let's make sure we're selected. So let's make sure we have selected everything and go to UV, export UV layout, and then name it whatever you want. So this is our final exported image. And this is our layout. And this is transparent as well, so you can just have it on top of this as another layer in our image editing software. And of course, once you have this, we can use it to create other maps as well, like normal maps, specular maps, whatever your shader has. This can be a really good reference to do that as well. So that is it for this video. Thanks for watching.